By 2050, it's anticipated we're going to need about 50% more food to feed the global population. And currently, most farming, especially in the United States, is done with chemical fertilizers. These have been fantastic for feeding the global population. Right now, it's estimated that the addition of chemical fertilizers feeds about half of the global population. So it's enabled Earth to sustain a global population above 8 billion people. The problem is its production causes a significant amount of greenhouse gases. About 2% of global greenhouse gases are just because of the Haber-Bosch process for nitrogen fertilizer production. It also damages native ecosystems, and a lot of it is wasted as runoff. And not only that, but where we're concerned, for farmers, it's increasingly expensive. And so farmers are now having to decide between applying the optimal amount of fertilizer or buying the right number of seeds or watering efficiently because their margins are so slim. Well, in nature, microbes do everything that chemical fertilizers do. So they can balance soil nutrients, they can improve crop stress tolerance, they can even secrete pesticides. So in theory, if we can formulate the right microbes, we can pretty much completely negate the need for agrochemicals in general. That's everything from fertilizers to pesticides. Not only that, but when people have added these microbial products to their farmland, even when they're still using chemical fertilizers, they see improved crop growth and yield. The problem, as you've probably gathered at this point, is that the microbes have to be alive. And just like our guts, much of the soil is not exposed to oxygen. And so these microbes don't like oxygen. They're very delicate. And when they're not in their native niche, in their native home, they're very hard to grow and manufacture. So when we thought about moving beyond human health, one of the microbes we wanted to target was Pseudomonas chlorophyllus. This is a really heat-sensitive microbe. So if you heat it above room temperature, about 25 degrees Celsius, it dies. That's a problem, right, for any sort of distribution, because you either then need cold chain, which is expensive and energy intensive, or you significantly reduce your yields. But this microbe is really cool because it can pull nitrogen gas out of the atmosphere and turn it into ammonia. So it can produce chemical fertilizers on site without any excess energy, without high temperatures and pressures, and it can also secrete antifungal compounds. So it can act as both a natural pesticide and a natural nitrogen fertilizer.